few minutes of everyone's attention. Just want to make sure that everyone is getting to parts A and B. So I'm sure you discovered that the reason the removal didn't work is because it wasn't implemented. And so now we need to implement it. And so my question is, how does one actually implement remove? So if you look at the data structure, what happens? Oh, I see. It shut itself off. Okay, well, it'll come on in a minute. So if you look at how this thing stores the elements, it has an array of items, or an array list of items. It'll become visible in just a minute. I'm just going to draw it as I speak so I don't lose track of it. And each item has 3 components. What was it? The key? I don't remember. What's an item? It has a key, a name, and a value. And so you have an array of these items. And if you look at the get method, it goes through the array of items and it tells you how to find one. Now, how do you remove one? So you have an array list, and now you want to remove an element in it. That's an interesting idea. So he says, let's replace it with null. I have never thought of that, but that's perfectly reasonable. And when you do replace it with null, then you're going to have to work harder in the put method, because at some point you want to reharvest those nulls. But that's not an unreasonable idea. What else can you do to remove? Here it comes up. So it looks like this, but if we ignore the fine structure, and we can just think of it as an array of items. So yes, each item looks like this, but we don't care. So so now let's say we found this item here, and we need to remove it. So what he says is, one could replace it with null, and that I suppose would be an option. But you don't want to have all these nulls that's sitting around, so at some point you need to find out some way of reharvesting them. But the next put might then need to look through and fill that null up again. What's another way you can remove something? Well, if you don't remove it, that's certainly an option. But then it's not really going to work, right? The next call to get is going to find it again. And so the semantics of remove is if you call remove and then you call get, then you do expect a null. So how else can you remove? What's that?
You said dot remove.
Okay. So you could call the remove method. And that is in fact true, and it makes me regret having used an array list here. So I'm going to amend the instruction to say you are not allowed to call the remove method in this lab. Yeah. So, because when you call the remove method, there's not enough that can go wrong. And the whole point for this lab is to deal with the possibility of failure. All right, so I will add that to that you can't use the remove method. The original lab was created with an array, not an array list, and arrays have no methods, so that was not possible. So, in fact, I'll need to make a note to re-implement it with an array for that reason. So let's say, yeah.
What do you mean?
I'm sorry?
So what do you mean?
Remove an entry means that you need to arrange your data structure in some way that the entry is no longer found. That the next call to get will not find it. That's entirely up to you. When you build a data structure, something that has a public API, what the private implementation is totally your choice. So when he said he's going to put in a null, I said that's fine. Because then when you, if you have an element here and you replace it with a null, then next time that someone calls get, it'll not find it, and that's fine. My only complaint is you can't just keep on adding nulls. That's inefficient. At some point you have to overwrite the nulls again. But what's like the, assume it was an array. How do you remove something from an array? You shift, right? So the normal way that people remove something is to do that kind of shift stuff. Yes. So you can do that. What is the other way that you can remove something from an array? If you don't want to shift. No one likes to shift. Does order matter in this array? It doesn't, because the only thing that we use it for is to make lookups with get and modifications with put, and each time we make a linear traversal through the entire thing. So it's actually, the order doesn't matter. So what you could do if you wanted to remove something is, let's say you want to remove this element here, you can take the last element and move it in here. So that would be the other option. You can shift or do that. So you can do one or two of those things. And so my question then is, when you do that, what kind of errors are you likely to get? None. You don't make errors. Really? I'm stunned. What? You must have written this kind of code before, and your program exited with some kind of error. What kind of errors do you typically get when you do this kind of work? What's that? Exactly, an array index out of bounds exception. Right? Anytime that you muck around with an array, there is a chance that you somehow mess up the indexes and you get one of these exceptions. And so the idea behind test-driven programming and test-driven design is that you say, these errors, they're a fact of life. They're going to happen. One will make errors when one does this kind of thing. And there are two ways of finding those errors. One is by building test cases that try to flush them out and systematically running those test cases every time. And the other one is by relaxing, by taking a trip to Mexico, then getting an irate call from a customer who says, my program isn't working, and then losing your job over it. So, both of those are ways that how you can find errors, but it's actually, if you think about it, a little bit better that if you try to find the errors before the product ships. So what people do is, as they design the program, as they design the data structure, they already start thinking about, how can I test this thing? And so then they, at that point, start building those test cases. And it's something that for a student is a totally unnatural act. Because the lifetime of your programs is how long? A week, right? After a week, you submit them and you never see them again. But of course, for real programs, it's completely different. Real programs live for a very long time, and so it's worth that extra effort of building these test cases. So that's what this lab is trying to walk you through, this whole way of thinking. What could go wrong? How can I write a test case that checks whether everything is right or whether there's something wrong? Writing the test cases first and then doing the implementation. All right, so I clarified the lab to make sure that I really wanted you to do some fiddly array removal, and then you'll get into the JUnit stuff on Thursday.